Let's start with a confession. Almost everything you've been taught about fat is wrong. For decades, our culture has waged war on adipose tissue. We've been told it's inert, useless, ugly, a passive lump of storage that only exists to make us feel ashamed. The multi-billion-dollar weight loss industry has built its fortune on convincing you that fat is the enemy, that if you could just eliminate it, starve it, burn it away, you would finally be healthy and whole. But what if I told you that this perspective isn't just unkind? It's biologically illiterate. What if the tissue you've been taught to hate is actually one of the most sophisticated, dynamic, and essential organs in your entire body? Fat is not just fat. Adipose tissue is an endocrine organ. Like your thyroid, your adrenal glands, your pancreas. It produces hormones, sends signals, and communicates with every major system in your body. It doesn't just sit there passively waiting to be burned. It actively participates in regulating your appetite, your insulin sensitivity, your inflammation levels, and even your reproductive function. The discovery of this reality is relatively recent. In 1994, a scientist named Jeffrey Friedman at Rockefeller University made a discovery that would revolutionize our understanding of metabolism. He identified a hormone produced by fat cells called leptin, from the Greek word leptos, meaning thin. For the first time, we understood that fat talks to the brain. It sends messages. It has a voice. Since then, the list of adipose-derived hormones, now called adipokines, has exploded. We now know that fat cells secrete over 600 different bioactive molecules. They influence inflammation, blood clotting, blood vessel function, and insulin action. Fat tissue contains not just adipocytes, but immune cells, blood vessels, nerves, and progenitor cells, all working together in a complex community. You don't just have fat, you have an adipose organ, and understanding how it works and what happens when it malfunctions is essential to understanding your metabolic health. Today, we're going to give adipose tissue the respect it deserves. We'll explore its structure, its signaling systems, and the critical difference between healthy fat expansion and pathological fat dysfunction. By the end, you may never look at your body the same way again. To understand what adipose tissue does, we first need to understand what it is, and it is far more complex than most people imagine. Let's start with the fat cell itself, the adipocyte. In white adipose tissue, which makes up the vast majority of human body fat, each adipocyte is dominated by a single massive lipid droplet. This droplet occupies about 90% of the cell's volume, pushing everything else: the nucleus, the mitochondria, the cellular machinery, to the periphery. It's essentially a specialized storage unit, designed to hoard energy in the form of triglycerides. But adipocytes are only part of the story. Adipose tissue also contains what's called the stromal vascular fraction, a diverse collection of other cell types that make fat a true organ. This includes blood vessels, a dense capillary network that delivers oxygen and nutrients and carries hormonal signals to and from the tissue nerve endings, both sympathetic and sensory nerves that allow brain adipose communication immune cells, macrophages, T cells, mast cells that patrol for damage and infection, adipose progenitor cells, stem cells that can differentiate into new adipocytes when needed, fibroblasts, cells that produce the structural framework holding everything together. This complex community works together to perform adipose tissue's many functions. In humans, we have two major types of white adipose tissue: and they are not created equal. Subcutaneous adipose tissue lies beneath the skin, primarily on your hips, thighs, and lower body. This fat has traditionally been considered metabolically protective. It's designed to store energy safely, away from vital organs. People with more lower body subcutaneous fat, the so-called pear shape, tend to have better metabolic profiles. Visceral adipose tissue surrounds your internal organs, the liver, pancreas, intestines, deep inside your abdominal cavity. This is the apple-shaped fat, and it's far more dangerous. Visceral fat cells are more metabolically active, more inflammatory, and more likely to release harmful substances directly into the portal vein that feeds your liver. We also have brown adipose tissue, a special type of fat packed with mitochondria that burns energy to generate heat. Once thought absent in adults, we now know that brown fat exists in small amounts and may be metabolically beneficial. And beige adipocytes, cells within white fat that can take on brown-like properties when stimulated by cold or exercise. This heterogeneity matters because different fat depots send different signals and have different impacts on your health. You cannot judge metabolic health simply by how much fat someone has. You need to know where it is and how it's functioning. This brings us to the most revolutionary aspect of adipose tissue, its role as a hormone factory. For most of medical history, hormones were thought to come from specialized glands, the pituitary, the thyroid, the adrenals. But we now know that fat cells produce and secrete a vast array of signaling molecules called adipokines. Through these adipokines, your adipose tissue talks to your brain, your liver, your muscles, your pancreas, and your immune system. Let's meet two of the most important. Leptin was the first adipokine discovered, and it remains the most famous. Leptin is produced by fat cells in proportion to how much fat you have. The more fat, the more leptin. Its primary job is to tell your brain about your energy status. When leptin levels are high, your brain should get the message. Energy stores are adequate. Stop eating. Increase energy expenditure. Leptin is your body's way of saying, we have enough, we're satisfied. But here's the tragedy of modern obesity. In most people with excess fat, this system breaks. Leptin levels are sky high, but the brain becomes leptin resistant. It stops hearing the signal. It's like shouting into a soundproof room. The message is sent, but it's not received. The brain thinks you're starving, so it keeps telling you to eat, to conserve energy, to hold on to fat. This is why simply telling someone with obesity to eat less is biologically naive. Their hormones are actively fighting them. Adiponectin is the opposite story. Unlike leptin, adiponectin levels actually decrease as fat accumulates. Adiponectin is a protective hormone. It enhances insulin sensitivity, reduces inflammation, and protects blood vessels. It's one of the few adipokines that is unambiguously beneficial. Higher adiponectin levels predict better metabolic health, lower diabetes risk, and reduced cardiovascular disease. When adipose tissue becomes dysfunctional, it shifts its production. Protective adipokines like adiponectin plummet, while harmful adipokines increase. TNF, alpha and I, L6. Inflammatory cytokines that promote insulin resistance. Resistin, as its name suggests, promotes resistance to insulin PAI1, promotes blood clotting and cardiovascular risk. Visfatin, linked to inflammation and dysfunction. Through these adipokines, your fat tissue influences virtually every aspect of your physiology. It affects whether you feel hungry or full. It determines how well your muscle takes up glucose. It influences your blood pressure, your clotting tendency, your inflammatory status. Adipose tissue is not a passive spectator in your health. It is a central player. This brings us to the most important distinction you need to understand: the difference between healthy adipose expansion and pathological adipose dysfunction. Here's a question. If fat is so dangerous, why do some people with significant fat stores remain metabolically healthy, while others with less fat develop diabetes and heart disease? This paradox has puzzled researchers for decades, and it reveals something profound. The answer lies not in how much fat you have, but in how your adipose tissue handles the load. Healthy adipose expansion occurs through a process called hyperplasia, the creation of new small fat cells from precursor cells. When you gain weight through this mechanism, your adipose tissue grows by increasing the number of adipocytes, not just their size. These new cells are insulin sensitive. They store lipids safely, and they're supported by new blood vessels that bring oxygen and remove waste. This kind of fat is pink, well perfused, and relatively non-inflammatory. This is the kind of expansion seen in metabolically healthy obesity, and even in the lower body fat of people with protective pear-shaped distributions. Pathological adipose expansion is completely different. Here, existing fat cells simply swell, a process called hypertrophy. They get larger and larger, stuffed with lipid, until they outgrow their blood supply. The tissue becomes hypoxic, starved of oxygen. Hypoxic fat cells send out distress signals, calling for help, and help arrives, but not the kind you want. Immune cells, particularly macrophages, flood into the tissue. These macrophages surround dying fat cells, forming what pathologists call crown-like structures. They release inflammatory cytokines, TNF-alpha, IL-6, that spill into the circulation and cause systemic inflammation. The tissue also tries to reinforce itself, laying down excess collagen, fibrosis, which makes the tissue stiff and less able to expand healthily. This creates a vicious cycle. The tissue can't expand properly, so fat cells get more stressed, more dye, more inflammation, more fibrosis. This is sick fat. And sick fat doesn't just fail to store lipids safely. It actively poisons the rest of the body. When adipose tissue reaches its limit, when it can no longer safely store additional lipids, something dangerous happens. The lipid has to go somewhere. And if it can't go into fat cells, it goes everywhere else. This is the adipose tissue expandability hypothesis, first articulated by researchers Virtue and Vidal-Puig. The idea is simple but profound. Every person has a finite capacity for healthy fat storage. Once that capacity is exceeded, lipid begins to accumulate in organs not designed for fat storage. And this ectopic fat is directly toxic. This process is called lipotoxicity. When fat spills into your liver, it causes non-alcoholic fatty liver disease. Now the most common liver disease in the world, affecting 1 in 3 adults. Fatty liver directly causes hepatic insulin resistance, meaning your liver can't properly regulate glucose production. When fat infiltrates your muscle, it creates intramyocellular lipid. These lipid droplets and their metabolites, particularly molecules called ceramides and diacylglycerols, directly interfere with insulin signaling inside muscle cells. Your muscle becomes resistant to insulin, unable to take up glucose efficiently. When fat accumulates in your pancreas, it impairs beta cell function. Remember from our previous episodes, pancreatic fat is directly linked to the loss of insulin secretion capacity. The beta cells, stressed by lipid overload, enter hibernation. When fat surrounds your heart or infiltrates your kidneys, it impairs their function as well. This is the true danger of metabolic disease. Not the fat you can see, but the fat you can't. The visceral fat wrapped around your organs, the lipid droplets inside your liver cells, the ceramides disrupting your muscle insulin signaling. And here's the cruel irony. This process is driven by adipose tissue that's simply trying to do its job. Your fat cells are not malicious. They're overwhelmed. They're sending desperate signals: high leptin, low adiponectin, inflammatory cytokines, trying to get your attention. They're saying, "I can't handle anymore. Help." This understanding forces us to challenge one of our deepest assumptions about body size. We tend to assume that thin people are metabolically healthy and larger people are not. But biology is far more nuanced. There's a phenomenon researchers call TOFI: thin outside, fat inside. These are individuals who appear lean. They may even have a normal BMI, but internally, they have significant visceral fat accumulation and fatty liver. Their adipose tissue has failed early, perhaps due to genetic factors, perhaps due to poor diet, perhaps due to an inability to create new fat cells through healthy hyperplasia. So even though they don't look fat, their organs are drowning in ectopic lipid. TOFI. Individuals are at high risk for metabolic disease despite their appearance. They may develop diabetes, fatty liver, and cardiovascular disease while being told by their doctors that they're healthy because their weight is normal. Conversely, there are individuals with significant subcutaneous fat who remain metabolically healthy. They have pink fat, well vascularized, non-inflamed, with plenty of small adipocytes. Their adipose tissue is doing its job, storing lipids safely away from vital organs. This is not to say that obesity isn't a health concern. It absolutely is, especially when it involves visceral fat accumulation. But it's to say that adipose tissue function matters more than adipose tissue mass. You cannot judge metabolic health by appearance alone. You need to look at what's happening inside. This understanding should free us from some of the shame and judgment we attach to body size, both our own and others. Metabolic health is not about aesthetics. It's about whether your adipose tissue is functioning as a healthy endocrine organ or as a sick, inflamed, failing one. So what do we do with this knowledge? If adipose tissue is a sophisticated endocrine organ, and if its dysfunction drives metabolic disease, how do we restore its health? The answer lies not in hating our fat, but in supporting its healthy function. First, we must reduce the demand. The primary driver of adipose stress is excessive energy intake, particularly from refined carbohydrates and sugars that spike insulin and drive fat accumulation. By choosing whole, minimally processed foods, we give our adipose tissue a manageable load. Second, we must improve the environment. Chronic stress elevates cortisol, which promotes visceral fat accumulation and directly impairs adipose function. Poor sleep disrupts the hormonal signals that regulate appetite and fat distribution. Addressing these foundational factors is not optional. It's essential metabolic medicine. Third, we must support healthy adipogenesis. Physical activity, particularly strength training, improves insulin sensitivity and helps create a metabolic environment where healthy fat expansion can occur. Some evidence suggests that certain foods, those rich in polyphenols, omega-3 fatty acids, and fiber, may support healthier adipose tissue remodeling. Fourth, we must be patient. Adipose tissue turns over slowly. Healthy changes take time to manifest. The goal is not rapid weight loss at any cost, which often triggers counterproductive hormonal responses, but consistent, sustainable improvement in metabolic function. Your adipose tissue is not your enemy. It's an organ trying to do its job in a challenging environment. When we understand it, respect it, and support it, it can return to health. And when adipose tissue heals, the rest of the body follows. This is the metabolic truth about the organ you never knew you had. And now you know. Thank you for watching. Please like, share, and subscribe, and turn on your notification as we dive deeper into the world of longevity and restoring your metabolic health.